Hi and good day everyone. So today we are going to continue with chapter 8 limits and continuity for SM015. So for this chapter we have 4 lectures, which is the first and second lecture. We are going to focus on the first subtopic, which is limits. There are several terms and keywords we need to learn here, which is the definition, the properties, method, one-sided limit, existent, infinite limits, and limits at infinity. And then we are going to continue with this third lecture, which is focusing on the second subtopic, asymptotes. So we are going to learn about vertical and horizontal asymptote. And the last lecture, which is the fourth lecture, we are going to focus on the third subtopic, which is continuity of a function at a point. So for the first subtopics, limits and continuity, we are going to focus on the basic knowledge about limits. Learning outcome of lecture 1. At the end of the lesson, students should be able to, the first one is to state the limits of a function as x approach to a given value a. So we write down the limit fx when x approach to a is equal to L. Okay, the second learning outcome is we are trying to apply the basic properties of limit. And then the third subtopic, we will try to find the limits when the division of limit fx when x approach to a and limit of gx when x approach to a when the numerator is equal to 0, also the denominator equal to 0. So what we have here is 0 over 0. So we are trying to find the limits of the division by following method. The first one is the factorization, the second one in the multiplication of conjugate. And then the fourth learning outcome for this lecture is to find one-sided limit. Means that we want to find the limit of fx when x approach to a from the right side, positive here, and limit of fx when x approach to a from the left. Okay, what is definition of limit? What we know about limits. So let's say a function fx is said to approach a constant L as a limit when x approach a as below. So this function fx will approach a value, a certain constant value L, when the value of x approach to a certain value of a. So we write down limit of fx when x approach to a is equal to L. This fx is the function which assume a corresponding set of values and x is the independent variable. So a key point here of the limit concept is that we are not interested in the value of fx when x equal to a. This is when we substitute the value of x here with a. No, we are not interested in that value. What we are interested is in the behavior of fx as x comes closer and closer to value of a. So what is the behavior when this x approaching to a certain value of a? Okay, so let's see the behavior of limit by following this example. So determine the limit of x squared plus 1 as x approach to 0. So how to find these limits? So what we can do first, we can try to find all the values of the function as x approach to 0. So how can we approach to 0? It can be either left side of 0 or right side of 0. So if we count some values, we substitute some value of x on the left side and the right side of 0, what we will have is, let's say we take negative 1, negative 0.5 and negative 0.2.5, negative 0.001. These all values are approaching to 0. And then the right side of 0 is 0.001, 0.25, 0.5 and 1. Okay, we just substitute this value into the function. But we can see the value of fx as we substitute the values here. We have 2, 1.25, 1.0625 and 1.000001. Okay, and the right side also we take we have the same value, and this value all approaching to what value? Okay, So it's actually approaching to a constant which is equal to 1. Means that as x approaches to 0 from the left and from the right, the value of fx will be approaching value of 1. That is the behavior of a limit of a function. Okay, so this is our graph. So if we sketch the graph of x squared plus 1, we can see all the value are converging into a value of 1. Okay, so the closer x gets to the value of 0, the closer the value of fx comes to 1. This limit could have been determined by simply substituting the x equal to 0 into the function of fx. So we get the limit of x squared plus 1 when x approaches to 0 from the left is equal to the limit of x squared plus 1 when x approaches to 0 from the right, which is equal to 1. Okay, so let's go down to the properties of these limits concept. So the first one, if fx is a constant function, then limit of fx when x approaches to a directly is equal to k. We just replace the function with k, so the limit will be k. And then if fx is equal to x, then the limit of fx when x approaches to a is directly the value of a. Why? Because this x will be replaced by the value approaching to a. And then if fx is equal to x to power of n, where n is a positive integer, then the limit of fx as x approaching to a, we replace the function with x to the power of n, is equal to this value of x replaced with a. So the answer is equal to a to the power of n. Okay, so the next properties of limit. So let's say we have k, a, and b, which is the real numbers, and limit of fx as x approach to a equal to a, and then limit of gx as x approach to a equal to b. Then we have the limits of k multiplied with fx as x approach to a equal to k multiplied with limits of fx as x approach to a, which is equal to k multiplied by a. So we factorize out the value of k here. Okay, so we factorize out the value of k, so the k will be the coefficient of the limit. And then the second one, if a limit of fx plus or minus of gx, so function of fx, subtract or add up the function of gx as x approach to a, then the limit can be separated into limit of fx plus or minus of limit of gx. So it will be a plus or minus of b. And then the third one is if a multiplication between two functions. So limit of fx multiplied with gx can be separated into limit of fx multiplied with limits of gx, which is equal to a multiplied by b. And then the last one is division of the two functions. So limit of fx over gx can be written equal to limit of fx divided with the limit of gx. So it is equal to a over b, where b must not equal to 0. Let's do some example. Example 1, find the following limits. A, limits of 5 when x approach to 3. So what is 5? 5 is a constant function. So what is the answer? Directly, it will just write down the constant itself. So the answer is equal to 5. And then for question B, limit of x when x approach to 4, it will be the value of a itself, which is equal to 4. And the last one, the limit of x to the power of 3 when x approach to 4 will be, yes, we replace the value of x with the value of a given here. So it will be 4 to the power of 3, which is equal to 64. Okay, we just have to apply the properties. Example 2. So we want to find the limits for the functions below. So for question A, so we want to find the limits 5x cubed where x approach to 2. So what we can do, we apply the fifth properties where we take out the constant 5 as the coefficient of the limits and multiply with the limit of x cubed where x approach to 2. So we just have to substitute the value of x here, which is 2, 5 multiplied by 2 cubed, which is equal to 40. And then for question B, limit of x cubed minus 10 when x approach to negative 1. So what we can do, this is a subtraction between two function. So we can separate the limit by finding the limits for each function and subtract. And then what we get here is limit of x cubed when x approaches to -1 minus with limits of 10 when x approaches to -1. So we substitute the value of x equal to -1 into the function. So we get -1 cubed minus 10, which is equal to -11. Question C. Limit of x squared multiplied with x plus 1 as x approach to 4. So what we can do, this is a multiplication between two functions. We can separate by multiply the limit of the function. So it will be limit of x squared multiplied with limit of x plus 1 as x approach to 4. So this function, we just have to replace the value of x with the value of a. So it will be 4 squared multiplied with 4 plus 1. So it will be 80. And question D. So limit of x divided with x squared plus 10 as x approach to -5. So now what you can do is to separate the limits of the division of the function. So it will be limit of x divided with limits of x squared plus 10. So what we know we have to do now, so this addition between two functions also can be separated. Okay, or we can just replace the value of -5 into the function, and then what we get is -5 divided with -5 squared plus 10. So what is the answer? It will be -5 over 35, which is -1 over 7. Okay, now for the C part of this subtopic, finding limits using factorization and multiplication of conjugate. Why we have to use this method? Okay, this is when the solution of the limits of the rational function is equal to 0 over 0. So we need to simplify the fraction by using factorization method or multiplication of conjugate. So let's say we use the factorization method. This is the example. We want to find the limit of x squared minus 9 over x minus 3 as x approach to 3. So basically, if we just substitute, we use the basic properties, what we have is equal to 3 squared minus 9 divided with 3 minus 3. So this is 9 minus 9 equal to 0. 3 minus 3 is equal to 0. So what we have here is 0 over 0. So we cannot find what is 0 over 0. So what we need to do is to do some factorization. Okay? So what we can factorize is the quadratic. So we cannot factorize minus 3 because it's the simplest form. So we have to factorize the x squared minus 9, which is equal to x plus 3 x minus 3. And then we can see here that x minus 3 and x minus 3 here can be cancelled out. So what's left here is x plus 3. So what is the limit of x plus 3 when x approach to 3? So it is equal to 3 plus t, which is equal to 6. This is not 0 over 0 already. So we get the value 6. Okay, multiplication of conjugate method. So this is the second method if we get the answer of 0 over 0. So for example, find the limits below. For the first question, limit of set x minus 1 divided with x minus 1 as x approach to 1. And then limit of x minus 1 divided with set x minus 1 as x approach to 1. Okay, what are the difference between these two questions is that we rearrange the numerator and denominator. So let's see how to solve this question. Okay, so for the next question is to find the solution for limit of set x minus 1 divided with x minus 1 as x approach to 1. Okay, so what we can do, because we have set here, what we can do is to just multiply with the conjugate of the set. So what is the conjugate of the set x minus 1? Yes, we have to change the sign of the second term, which is from negative will be positive. So we are multiplying both numerator and denominator with set x plus 1. Okay, now what we should do, because it's a conjugate of set x minus 1, we have to expand the numerator here. Set x minus 1 multiply with set x plus 1. But for the denominator, we don't have to expand. Why? The tips here is we want to cancel some of the terms here. Okay, so let's do some the expansion of the numerator. So what we get is third x multiplied with third x will be x. So negative 1 third x, positive 1 third x will be cancelled with each other. Negative 1 multiplied with positive 1 will be negative 1. So what we have here is x minus 1 over x minus 1 multiplied with third x plus 1. So we can see here that x minus 1 on the top can be cancelled out with the x minus 1 in the denominator. So what's left for this limit is limit 1 over third x plus 1 as x approach to 1. So what we need to do is just substitute the value of 1 into the function we have here. So the answer will be 1 over third 1 plus 1, which is 1 over 2. Okay, let's do for the second question. So limit x minus 1 divided with third x minus 1 as x approach to 1. So what we need to do, the same as the first question, we just have to multiply with conjugate of the third, whereas the third one will be in the denominator part. So what we need to expand, we expand the denominator while letting the numerator as it is. Okay, so what we get as the denominator, so the same results as the first question will be x minus 1. And then notice that we can cancel out the x minus 1 on the top with the denominator. So what's left is the limit of third x plus x as x approach to 1. And by substitute the value of 1, we get third 1 plus 1, which is equal to 2. Okay. Okay, the next subtopic, which is equal to one-sided limits. So the fourth one, D, one-sided limits. So what it means by one-sided limits? Okay, let's say this is our function. So we have a function, and then we notice that from the left side of the function, the value are approaching to 0. 0 of value of y. While from the right of the function, it's approach to value of 1. Okay, so the right limit, the limit from the left side is not the same as the right side. Okay, because it will be different. It can be different, especially if we have the piecewise function. A one-sided limit can either be right hand limit or left hand limit. So we can find either one of these two limits. Right hand limits. So limit of fx when x approach to a, positive. So we have a notation positive at the top of value of a. So this is a right hand limits equal to L. So how we pronounce this representation? Limits of fx as x approach to a from the right. And then this limit as x approach from the right is L. And then from for the left hand limit, so limit of fx when x approach to a, negative. So this negative indicates the left hand limit equal to m. So how to pronounce? The limit of f as x approach a from the left is m. Okay. So let's do some example. Evaluate each of the following limits. So for question A, limit of x cubed minus 2x plus 7 when x approach to 2 from the right. And then for question B, limit of x minus 5 divided with x squared minus 25 as x approach to 5 from the left. So how to find the limit? So for question A, limit of x cubed minus 2x plus 7. So directly we can replace the value of 2 into the function. 2 cubed minus 2 multiplied by 2 plus 7. So directly we get the answer equal to 11. So what's the difference? Okay, because it's just the same function. Okay, so for question B, x minus 5 over x squared minus 25 as x approach to 5 from the left side. Okay, so what we can find out here, if we substitute directly the value of 5, so we get 5 minus 5 and 5 squared minus 25. This is equal to 0. This one also equal to 0. So this is 0 over 0. So what we can do, we can apply the two methods, either factorization or, yes, multiplying with conjugate. For this one, do we have any third or No. So we can do, what we can do is to factorize. So we factorize the numerator because we have quadratic in the denominator. We can factorize the denominator, sorry. Okay, so what we get here is limit of x minus 5 divided with x plus 5 multiplied with x minus 5. So we can cancel out the x minus 5 here. So what we have is limit of 1 over x plus 5 as x approach to 5 from the left side. Okay, so just substitute the value of 5. So 1 over 5 plus 5 equal to 1 over 10. Okay, thank you. This is for the first lecture. So we are going to continue with the second lecture to finish the 8.1 subtopic.